And the next thing we have to talk about is internal capsule. So what about the internal capsule then? See, we have some idea, but this idea we have to use in a question. What do you think is the answer? This is asking for relations of internal capsule, some projection fiber, dividing corpus striatum into laterally lentiform, medially caudate. What is your answer? Okay, if you say this is the answer, can you tell me one thing? What is between the thalamus and the lentiform? That was which limb of the internal capsule? The posterior limb. And where is the anterior limb sandwich between? It is between the caudate and the lentiform. So this is the orientation which you already have, but keep the answer, and then you have to talk more about the internal capsule as you're doing. This is internal capsule you have seen already. There is one anterior limb which is sandwiched between caudate more medially, and then you were having the lentiform laterally, and thalamus is actually more medial. And this is the diagram. So this is superior view of the brain on the right side of brain. Yes, superior view of the brain and right side of the brain, showing anterior limb, posterior limb, and the bend called genu. And then you will see this is the lentiform nucleus which is lateral to the internal capsule, and head of the caudate nucleus is medial, and also the thalamus is medial. As you say so, you will find that this is corticonuclear tract, which is passing through the genu of the internal capsule, is a part of the pyramidal system and moving the face muscles like the eye muscles. You remember we were putting a thread into needle. To put thread into needle, you have to look at the eye of the needle, and you move your eyes using corticonuclear tract. And corticonuclear tract is passing through the genu of the internal capsule. You mean to say corticonuclear tract control the head muscles like the eye muscles, and the fibers are pyramidal system passing through the genu? Yes. And what about the finger muscles? Because I have to move fingers now to put the thread. That is corticospinal tract, part of the pyramidal system. And where is corticospinal tract passing? That is passing through posterior limb of internal capsule. Can you see one thing here? The human body being represented in anterior posterior direction. The head is more anterior and upper limb, lower limb, like that. So the fibers of the head are passing through the genu, whereas the upper limb or the lower limb fibers are passing through the posterior limb of ventral capsule. See, this is corticospinal tract, which is controlling the upper limb and the trunk region and the lower limb fibers. They are in the posterior limb of ventral capsule, whereas the head fibers were in the genu. That representation we have to draw ourselves as well. So putting a thread into needle, first thing is I have to move my eyes because I have to look at the needle, you know, the eye of the needle. So corticonuclear tract, yes, and then corticospinal tract. This is corticospinal tract. Total, two things are pyramidal system. Corticonuclear tract is for moving the eye in the genu. Corticospinal tract is in the posterior limb of ventral capsule to move the fingers. And what will happen if I have a lesion on the right side of the brain? If you have a lesion on the right side of the brain of the internal capsule, there will be problems on the left side of the body involving the head and the body if the genu and posterior limb is involved. And what if only genu is involved? There can be a problem, only posterior limb involved. If only posterior limb is involved, then the problem will be restricted to upper limb, trunk and the lower limb. Face area spared. That came as a question also. Face area will be spared. And what if the genu is involved? Then the body is spared. Because if there is a ischemia in the genu of ventral capsule, sensory motor loss will be on the opposite side of the face. So, ischemia in the genu of internal capsule, sensory motor loss on the opposite side of the face. Yes. Not the body. No. Corticonuclear tract is compromised, you know. Face muscles, sensation will be compromised. So, keep that idea. Now, we will talk about metathalamus. Metathalamus is two geniculate bodies, and the two geniculate bodies are medial geniculate body and lateral geniculate body. The medial geniculate body is for music pathway, that is auditory pathway, and the lateral geniculate body is for light pathway, which is the visual pathway. Let us look at the music pathway first. So when you're talking about the music pathway, the medial geniculate body for music pathway, auditory pathway, you see it is some fibers passing through internal capsule. Now, which part of internal capsule it is passing through? Actually, these are fibers going to reach the hasal gyrus. What is hasal gyrus? Hasal gyrus, superior temporal gyrus, area number 41, 42. So, you are telling that this auditory pathway is going to reach the hasal gyrus, which is the superior temporal gyrus, area number 41, 42? Yes. Okay. And which part of internal capsule you are using? This is called as sublentiform fibers of internal capsule. Why would you say sublentiform? Because they are passing under the lentiform nucleus. So these fibers are passing under lentiform nucleus. That is why sublentiform fibers. Yes, sublentiform fibers of internal capsule come in the auditory pathway. It is the posterior part of internal capsule. So they are using the posterior part of internal capsule. Yes. And what about the visual pathway? That is the light pathway, lateral geniculate body, and going towards the occipital visual cortex. And occipital visual cortex is also area number 17. It is called as striate cortex. Why it is called striate cortex? Because there are some striations of Jenari. Some striations of Jenari. Yes, striations of Jenari. So there are some striations of Jenari's in the occipital visual cortex, area number 17. That is why you are telling that this is a striate cortex. Yes. What is the pathway like? The lateral geniculate body is sending the optic radiation towards the area number 17 towards the calcarine sulcus. This is also called geniculocalcarine tract. Why will you say the optic radiation is geniculocalcarine tract? Because coming from the lateral geniculate body and going to the calcarine sulcus, geniculocalcarine tract, the optic radiation, and is passing behind the lentiform nucleus. And because this pathway is passing behind lentiform nucleus, it is using some part of the internal capsule. That part of internal capsule is called retrolentiform fibers of internal capsule, because it is behind the lentiform nucleus. So behind the lentiform nucleus, there are some retrolentiform fibers of the internal capsule. The posterior part of internal capsule again, yes, that you remember. Now also remember that there is anterior choroidal artery, branch of internal carotid artery supplying posterior limb of internal capsule. What will happen if it is having a block, some syndrome? One of the AIMS question, anterior choroidal artery syndrome. So you are telling that there is some anterior choroidal artery syndrome? Yes. Due to a block? Yes. They are asking what clinical features are seen, what are not seen, except. So you are mentioning anterior choroidal artery is a branch of internal carotid artery. Yes. And it supplies the posterior limb of internal capsule. Then I will tell you the clinical features. There will be some visual problem. Can you tell me which visual problem? Homonymous hemianopia. Homonymous hemianopia. So you are telling some ischemia here. So there is some visual pathway involved leading to some homonymous hemianopia. Yes. And what else? There are some auditory problems. There are some sensory motor problem. Where is the sensory motor problem? The face. No, not the face. Why not the face? Because this is sensory motor loss on the upper limb and the trunk and the lower limb, not the face. Why not the face? Because the genu part of internal capsule has a separate artery supply. What is that separate artery supply? Actually, it is supplied by a direct branch of internal carotid artery. Direct branch of internal carotid artery. So there is a direct branch of internal carotid artery supplying the genu of the internal capsule. Yes. So corticonuclear tract is still working. Yes. Since internal carotid artery gave a direct branch towards the genu of the internal capsule, the corticonuclear tract is working. There is no sensory motor loss on the face, but it is restricted to lower body, which could be upper limb, trunk and lower limb, depending that whether the anterior area involved or posterior area involved. So that you remember. Internal capsule blood supply we'll discuss later as well. At this moment, you look at this question. It is asking anterior choroidal artery syndrome. It's a branch of internal carotid artery. So what is not seen? Yes, of course, you know the answer because it is not supplying the anterior limb. Then who is supplying the anterior limb of internal capsule? Actually, anterior cerebral artery. Which branch of the anterior cerebral artery? It is called recurrent branch of Hübner, which we will discuss in a diagram later as well. So telling that anterior caudal artery supply the posterior limb of internal capsule. Yeah, that's why there's no problem with anterior limb. So there will be anterior limb of internal capsule supplied by anterior cerebral artery, and which is a recurrent branch of Hübner. That is the answer. Yeah. So there will be homonymous hemianopia. Yeah, that is there. And there will be some sensory motor loss. Where is the sensory motor loss? Face. No, not the face. The sensory motor loss will be on the upper limb and the trunk and the lower limb, not the face, because this is going to compromise posterior limb of internal capsule. So keep your answer as choice number. You are supposed to keep your answer as choice number C and move further. As you are moving further, you will see this is, we are going to draw a diagram for the internal capsule here. And the diagram which we are drawing for internal capsule is again a superior view of the brain, and we are looking at the both sides this time. So let's do it. You see, this is the midline of the body, and that is the thalamus on each side. And we already have described that there will be lentiform nucleus which is actually anterolateral to the thalamus. And this lentiform nucleus, as you are telling, there will be a caudate nucleus anteriorly. So this kind of orientation you already have. There is the two thalami, and these are the two lentiform nuclei, and these are the two caudate nuclei. We are not focusing upon them. We are actually talking about internal capsule here. So what about that? You see, this is the internal capsule here, sandwich between the various nuclei, having anterior limb, sandwich between the anterior limb of internal capsule, sandwich between the lentiform lateral and the caudate medial. So anterior limb of internal capsule sandwich between lentiform lateral, caudate medial. What about the posterior limb? Posterior limb is sandwich between the lentiform lateral and thalamus medial. Let us draw the internal capsule on the other side as well. So you are drawing the internal capsule on the other side as well. Yes. Now, once you have drawn the internal capsule on both the sides, this is the superior view of the brain and right-sided internal capsule, the superior view of the brain and left-sided internal capsule. Then you have to tell the human body is like this, represented on the internal capsule, means the sensory motor fibers of the head area are passing the genu of internal capsule, whereas the upper limb, lower limb and the trunk sensory motor fibers are passing in the posterior limb of the internal capsule. Now, once you have that orientation, let us discuss more details. Actually, when you're talking about the human body here, this is the head and this is the trunk region, upper limb, lower limb region. This is upper limb, that is the lower limb. Understand, if I want to move the muscles, then I require pyramidal system, and pyramidal system has two components, corticonuclear tract and corticospinal tract. If I want to move the eye muscle, corticonuclear tract, and if I want to move the finger muscles, then corticospinal tract. So understand, pyramidal system has two components. One is called corticonuclear tract, which will help me to move my eye muscles, to look at the eye of the needle, and if I want to move my finger to put the thread into that, I need corticospinal tract to move the upper limb. Together this is pyramidal system. Let us represent that in the internal capsule, the fibers, and this is the bend called genu. Now when you say this is the bend which is called genu, that is where you will have corticonuclear tract. But remember that corticonuclear tract which is passing to the genu, the motor fibers are passing more lateral. So motor fibers are passing more lateral means corticonuclear tract will be passing more lateral. Yes. Then we will be passing more medial, the sensory fibers. And who will be carrying the sensory fiber from the face? That we will discuss. But here it is motor fibers which are passing more lateral. So what about the corticospinal tract? It is also here more lateral. Now you are telling that it is also lateral corticospinal tract. Yes. You're telling that if I want to move my eyeball muscle, corticonuclear tract fibers are passing in the genu but more laterally. Yes. And if I want to move my fingers, then I have to use corticospinal tract fibers which are passing more laterally but in the posterior limb of internal capsule. Yes, posterior limb. And what if I touch the face? If you touch the face, then trigeminal fibers are activated. This is sensory components now. So when you're talking about the sensory components, you will touch the face, trigeminal fibers are activated. Where do you think the trigeminal fibers pathway will be passing? Genu. Which part of the genu? Here. Now you can show. Let me show it in blue color. So blue color, some dots. Yes, blue color, some dots. Because that blue colors and dots is trigeminal pathway. So you're telling that you are touching the face now. Yes. Which pathway activated? Trigeminal pathway. And where is the trigeminal pathway passing? The genu, but more medially. If you say trigeminal pathway is passing the genu but more medially, what if I touch the upper limb, lower limb? If you touch the upper limb, lower limb, yes, touch the upper limb, lower limb. If you are touching the upper limb, lower limb, you will activate two tracts. What are the two tracts activated? One is the dorsal column spinal cord, the other is spinothalamic tract. So when you touch the upper limb or when you touch the lower limb, you will see that two tracts are activated, named dorsal column of spinal cord and spinothalamic tract. So dorsal column and spinothalamic tract, where the fibers passing? Obviously in the posterior limb of internal capsule, but more medially. Remember, sensory fibers are more medial. The point is dorsal column pathway and spinothalamic tract pathway, which carry touch sensation of the upper limb, lower limb trunk region, will be running more medially. What is the use of knowing all that? Use of knowing all that is simple. If you have ischemia in the genu, where is the sensory motor loss? On the face. And what if you have ischemia in the posterior limb? Where is the sensory motor loss? On the upper limb, lower limb. And what if the ischemia is more lateral? Only motor problem. If the ischemia is more medial, only sensory problem. That is the clinical application. Now, look at the medial geniculate body, lateral geniculate body. Lateral geniculate body is for the light pathway, this is lateral, so light pathway, yes, and M for the music pathway, the auditory pathway. You mean to say medial geniculate body? Yes. So, together this is called as metathalamus. Metathalamus. What is metathalamus? Metathalamus is diencephalon, and any thalamus is diencephalon, and metathalamus is having lateral geniculate body for light pathway, visual pathway, and the medial geniculate body is for music pathway, auditory pathway. Let us discuss the two pathways again. This is the medial geniculate body, and where is the pathway? The pathway from medial geniculate body use the posterior part of internal capsule, pass under the lentiform nucleus and reach the area number 41-42. That is the superior temporal gyrus, auditory cortex. So you're telling that this is medial geniculate body sending some fibers passing the posterior part of internal capsule, passing under the lentiform nucleus to reach the area number 41-42, which is superior temporal gyrus. So I think this is the temporal auditory cortex, yes, and as you have known earlier, this is called as sublentiform fibers of the internal capsule. Why would you say this is sublentiform fibers of the internal capsule? Because they are passing under the lentiform. So this is sublentiform fibers of internal capsule carrying the auditory information because called so passing under lentiform. Yes, and what about the visual pathway? Visual pathway, let us see. You can draw the lateral geniculate body now, and lateral geniculate body, what is it doing? It is sending this pathway now. As it is sending the pathway using posterior limb of the internal capsule, it will go to the calcarine sulcus, and as it is going to the calcarine sulcus, you will see this is area number 17, the occipital visual cortex, which is also called striate cortex. Why it is called striate cortex? Because it has striations of Jenari. So you are telling that this is area number 17. Yes, the Area of calcarine sulcus, right. Occipital visual cortex or the striate cortex, because there is some striations of Gennari here. Yeah, striations of Gennari. Striate cortex. What is this pathway? That is the optic radiation. If you say that is the optic radiation, what is the other name? Other name we have known, it is also called geniculocalcarine tract. Why would you say it is geniculocalcarine tract? Because coming from lateral geniculate body and going to the calcarine sulcus, the geniculocalcarine tract. Do you remember which part of the internal capsule it is using? Posterior part? Yeah, posterior part. But which part of the internal capsule it is using? Behind lentiform. Behind lentiform means the retrolentiform fibers. Retrolentiform fibers of the internal capsule. Why would you say retrolentiform? Because see here, this is the lentiform nucleus. And because this is the lentiform nucleus and fibers are passing behind the lentiform nucleus, that is why they are called as retrolentiform fibers. This is the visual pathway. This is what we wanted to discuss regarding the internal capsule, various parts, various pathways, tracts passing through that. This question is asking what is not passing through the posterior limb of internal capsule. What do you think is the answer? If you say what is not passing through the posterior limb, then I will say the answer is yes, the corticonuclear. Why? Because it is in the genu. If it is in the genu, then what is in the posterior limb? It is not corticonuclear. It was actually corticospinal tract. So there you have corticospinal tract. Yes, not the corticonuclear. No. This is the answer because corticonuclear tract will be passing in the genu of the internal capsule because posterior limb has corticospinal tract. So you mean to say sublentiform fibers are there? Yeah, they are there. Corticonuclear tract is your answer because it is a genu. Sublentiform fibers are nothing but the auditory pathways, and retrolentiform is nothing but the visual pathways. And do you remember there was a dorsal column as well as the spinothalamic tract carrying the touch sensation of upper limb, lower limb, passing the posterior part of internal capsule. So that is why we will keep our answer as corticonuclear tract.